In this program, we're going to have a right triangle with two legs, and we'll be able to determine the hypotenuse, the perimeter, and the area of the right triangle. And we're going to use functions to make this happen. Much of the code is already written. You can see that if we type in the numbers 6 and 8 for the legs and press calculate, there's no errors on that. If we type in a letter like W, a try-catch has already been set up, and that's going to generate an error message. Here's much of the code already written for us, and some goals at the top. We're going to learn how to write and call or activate functions, how to document functions, and at the end, take a look at how we can keep a form its same size. Got some variables already ready to go in the btn calculate click event. Two variables set up for the legs. That's what's in the text boxes. We're also ready to find out the hypotenuse, area, perimeter. They will all be doubles, and a string comparison of the legs. Inside the try-catch, we're obtaining the values of leg 1 and leg 2. And then we have some calculating to do. But instead of doing all that calculating here inside this calculate button click event, we're going to make functions. Functions are sets of statements like we saw with subs and procedures. However, they must return a value when they are done, and this can be very handy. We'll call this function calc hypotenuse. We could have capitalized the C in front. I didn't do it this time, not a big deal. You notice that the name of the function is in red because we don't have an as clause. We have to say what the return type will be. So it's as double. This function, when it's done, will return a double. The reason why end function has a green squiggle underneath is because currently nothing's being returned. We notice that we're going to send two values down here, and they're the values of the legs. We'll use by val, as we've seen so far with subs. We'll learn later on about the difference between by value and by reference. And we'll just call these A and B, DBLA and DBLB, to represent the two legs of the right triangle. We're going to use some documentation. You could either put this right inside the function or right at the very top. We explained that we're going to return the hypotenuse, and we explained what the two parameters are going to be. That's what DBLA and DBLB are. They are parameters, parking spots, ready for values to be sent down. And they are each legs of a right triangle. Next, we're going to declare a variable that will serve as our return value. I'll call it DBLHype, and it will be a double. Not a surprise, that matches the data type we're going to return. Remember, this function is supposed to return a double, so this value I'm going to return, we're going to declare that as a double as well. Let's use the Pythagorean theorem to calculate the hypotenuse of this right triangle. So the hypotenuse, well, we know that c squared will equal a squared plus b squared. So there's the a squared and the b squared. We'll have to take the square root of a squared plus b squared to get the actual length of the hypotenuse. We'll use math.sqrt and then put all that in parentheses. Math.sqrt is a function itself. It returns a value, the square root of whatever is sent to it in parentheses. Now DBLHype equals the hypotenuse. We're going to return it. So here is the return statement the function is expected to have. You notice the green squiggle has disappeared from the end function because we are now returning a value as promised, and it's a double. So we'll call or activate this function back in our calculate click event for the button. DBLHypotenuse, a variable we've already declared, will equal the result of this function, calc hypotenuse. Notice we're expecting two values. We're going to send it DBL leg 1 and DBL leg 2. Now it matches what the function is expecting. We have a display output sub ready right now. It's expecting four values: the hypotenuse, the area, the perimeter, and a comparison of the legs. We've declared variables for these things in this button click event for calculating. We haven't assigned values to them, so those doubles equal 0 and the string is empty. But it allows us to test what we've done so far to see, do we actually get a hypotenuse? Well, we'll try the classic 3, 4, 5 right triangle. There it is. Looks like we're in good shape with our hypotenuse calculation function. Next, we're going to need to calculate the perimeter. That means we're going to add up all three sides. So we'll make a calc perimeter function. It's going to need 3 parameters. Side 1, side 2, and side 3. They're all doubles. So we'll do bival dbl side 1, bival dbl side 2. And you'll notice that I forgot to use bival on side 3. Well, bival is the default anyway. This function will return a double, so we have to say as double at the end. Of course, end function has still got a green squiggle because we are not returning anything yet. But we are going to return the perimeter of a triangle. We'll put that in our documentation. And we'll explain what each parameter is. Side 1, side 2, and side 3. They're each sides of a triangle. As we did in the previous function, we'll declare a variable that will hold our return value. This time we'll just call it dbl answer. Kind of generic, but that's okay. We'll explain right here that it's the value we're going to return, the perimeter of the triangle. In fact, this one will work for any triangle, not just a right triangle. To calculate perimeter, we've got to add all 3 sides. That's what will make dbl answer equal. And now it's ready to return. And we have to return a value if we got a function. Notice the green squiggle will now go away on end function because we are returning a value as promised. We promised we would return a double, and that's what we're doing. We'll come back up to the calculate click event on the calculate button, and dbl perimeter is a variable that we've already got. We'll set it equal to the result of the calc perimeter function. We've got to send it dbl leg 1, dbl leg 2, and dbl hypotenuse to match the 3 parameters, parking spots, that are expected to be filled. Those 3 are arguments up here, and they will arrive in those parking spots in the function. We'll try the classic 3, 4, 5 again, and it works. 3 plus 4 plus 5 is 12. Well, we've got to calculate the area of this right triangle. We'll make a function for this as well. Again, we'll start with this. We'll make it a private function. We'll learn more about private and public later in the class. We'll call it calc area. Once again, we could have capitalized the C on calc area. That would be all right. We've got to have 2 parameters. We need to know the 2 legs. This time we'll call them leg A and leg B. I'll put dbl in front because they are going to be doubles. We have to say what data types these are coming into these parameter parking spots. And I know that this is going to return a double as well. Once again, above the function, or you could do it right inside the function, we're going to explain what its purpose is and what you can expect it to do. It's going to return the area of a right triangle. And we'll explain the 2 parameters. Leg A and leg B are each one leg or another leg of a right triangle. But you know, this really is a right triangle area function. So let's give it a better name, calc right triangle area, because you just can't send 2 sides of any triangle to get an area, but you can for a right triangle. That would be important if we want to take this function to another program. Well, we will declare dbl answer as double, like we did for the perimeter calculation. It's the value we're going to return. It is a double because we've promised to return a double, and it will represent the area of the right triangle. Well, the area of a triangle is 1/2 base times height. In a right triangle, the legs are the base and the height. We'll just use 0.5 for the 1/2. And now we're ready to return our answer. As promised, it is a double. We said we return a double. We are returning a double. So we can come back to the calculate click event on that button. We already have a variable called dbl area in this, and its value will equal the result, what is returned from calc right triangle area, the function. It's expecting 2 things to be sent to it. Here are the 2 arguments, dbl leg 1 and dbl leg 2. Those arguments will arrive in the parking places down in the function. Let's see if it works. Once again, the classic 3, 4, 5. 3 times 4 is 12, and half of that is 6. And you notice it's very easy to read the code in the calculate click event. Well, we also want to compare the legs to see if one is longer than the other or if they're equal. This time we're going to have a function that will compare the legs. We will send it the two legs, so we'll set up two parameters, two parking spots, one for leg 1, one for leg 2. This time we'll use words for 1 and 2. And we're going to return a string. The string will be some statement explaining whether leg 1 is longer than leg 2 is longer than leg 1, or they're equal. We've explained that in documentation above the function. We're explaining what the two parameters are. Again, the parking places that are expecting arguments to arrive. We'll declare a variable as a string that will be our return value. We'll call it str result. And this is the value we're going to return, some kind of statement about which leg is longer or if they are equal. And we'll use an if to determine what we should say. If it turns out the two legs are equal in length, then we'll have str result equal a statement that the legs are equal. If it turns out that leg 1 is longer than leg 2, then our string will reflect that. And once again, we'll put it in str result. The only other option is leg 2 is longer than leg 1. Now str result is ready to return. Of course, we will document this if block. We should always document an if block. And we'll return str result. We can head back up to the calculate button. We've got a variable already declared called str leg comparison, and we can set it equal to the result of the function we just wrote, the compare legs function. It returns a string value. That's good because str leg comparison is a string. We've got to send it two arguments, dbl leg 1 and dbl leg 2. That's what it's expecting. Let's test it out. With this 3, 4, 5 triangle that we've been trying, leg 1 is shorter than leg 2. So there it is. Leg 2 is longer than leg 1. In this case, leg 1 is longer than leg 2. If we put 10s inside both, which would also be a 45, 45, 90 triangle, leg 1 and leg 2 are the same length. And those other values are also accurate. We've got to copy and paste an error message there in case we have a negative number put inside the text box. Let's see if that works. It does. Another thing that we said we'd check out in this program is how to keep a form its same size. In the properties of Form 1, you notice the maximum and minimum sizes have been set to the same values, and the maximize box is currently set to false. Nothing happens if you try to maximize the window. If we change this to true for the maximize box, you'll see that the size really doesn't change when we try to maximize it because the maximum size and minimum size have been set to the same values. If we switch the maximum width to something a little longer, 600, then it can get a little wider on the maximize box. Notice that it is a little wider. We'll go ahead and change that back to 500. And we'll set the maximize box to false. So users don't have the ability to maximize the form. It's simply not enabled. With all these functions, it's a lot easier to read the btn calculate click event than if we had put all the code inside there. We send them out to these functions, which we could copy and paste to another right triangle program. You notice that none of these functions refer to anything directly on the form. They could be reused in other programs. In fact, the calculate perimeter function could be used in any triangle program. We could simply copy and paste those functions. And speaking of using things over and over again, we have a sub here called clear results. We had to use it anytime a text box was changed and also when things were reset.